7. We're going to start in section 7.1, which are trigonometric identities. And so we're going to start using these. We'll slowly build up to make these more and more complicated, and then we'll start solving trig equations. So let's start with the reciprocal identity. So cosecant is 1 over sine. We kind of talked about this. Secant is 1 over cosine. Cotangent is 1 over tangent. Tangent is sine over cosine, and cotangent is cosine over sine. And so one of the things we can use here is that we can convert all the trig functions into sines and cosines. And so that's if you get kind of stuck, you can kind of do that. We've done the Pythagorean identity. So sine squared plus cosine squared equals 1. Tangent x plus 1 equals secant, and cotangent 1 plus cotangent squared equals cosecant squared. Notice these are all really the same, because here if I took this and divided everything by sine squared x, so this becomes 1 cosine over sine squared, cosine squared over sine squared x. That's the same as cotangent squared, and 1 over sine squared x is cosecant squared. And so we can see that all these are the same. We can achieve this one just by dividing by cosine. So these are the same thing, just written 3 different ways. We have our even and odd identity, so sine of negative x is equal to negative sine of x, and cosine, which means it's odd. This is odd. And this is even because if I plug in cosine negative x, I just get cosine of x, and therefore tangent of x is odd, because I'll have a negative up top and a positive down below, so it just keeps it negative. The cofunction identity, so here if I take pi over 2 minus x, I get sine of pi over 2 minus x is cosine. You can do the same for tangent to get cotangent, and secant gives you cosecant. Sine gives you cosine, and so this is why they're called cofunctions and why they're given what they are. So let's start in by simplifying expressions. So when you first start doing this chapter, it's going to seem very weird because you probably haven't worked too much in this, and they're kind of like little mini proofs that we're going to work through one step at a time. So I'll work through some with you. You'll work through some with your students on the discussion board. So please use the discussion boards during this time, and we'll go ahead and work through this stuff. And so here, if I want to simplify this expression, so here I don't know what to do. So I'm just going to convert everything to sines and cosines. So here I'll have cosine of t plus tangent is sine of t over cosine of t times sine of t. Well, if I want to put these two together, if I want to add them together, I need to make them have the same denominators. This has cosine, this has a 1 for a denominator. So I'm just going to multiply by cosine t times cosine t, because this is anything over anything is 1, right? So cosine t over cosine t is 1, and so here I can get this, so this would be cosine squared plus sine squared, so it would be squared plus sine squared all over cosine of t, right? And so here, I converted everything to sines and cosines, and then I want to put these two together, so I make them have the same denominator. How I did that is I multiply by 1, aka cosine t over cosine t. Cosine times cosines, cosine squared, sine times sine is sine squared, and then we have our denominator of cosine of t. Notice that sine squared plus cosine squared is 1. And so we're just going to write this as 1 over cosine of t, and cosine of t is secant of t. So this all just equals secant of t. Okay. Let's go on to the next page. Let's try something a teeny bit more complicated. So we want to simplify this expression. So when I'm looking at this, I'm thinking, okay, so what's the first thing I want to do? Well, I want to put it together. So here I have a 1 plus sine and a cosine. So here I'm going to multiply. I'm going to take sine of x over cosine of x. I'm going to say this is 1 plus sine of x, because I want to get, and then 1 plus sine of x. So I'm just multiplying by its denominator plus cosine x over 1 plus sine of x, and then in order to get this to add up together, we're going to have cosine x over cosine x. And so I'm just multiplying by this denominator. So here I'm just making the fractions come together. The only difference here, instead of using numbers, we are using trig functions or expressions, right? Here I have 1 plus sine of x over 1 plus sine of x. Alright, so what do I have up top? Well, here I'll have 1 plus sine of x times sine of x. So 1 plus sine of x times sine of x plus cosine x squared, or cosine squared x. And then on the bottom I'll have 1 plus sine of x cosine of x. Alright, so let's go ahead and work through this. Let's go ahead and distribute this. So I'll have 1. So I'll have sine of x plus sine squared x plus cosine x, or cosine squared x plus 1 plus sine of x cosine x. And so here I'm just distributing the sine into here. So I get sine of x. Notice that this is 1. Okay? So this is equal to 1. And so here I'll have sine of x plus 1 over, oops, got my parentheses. 1 plus sine of x cosine x. And notice here I have the same thing on top and bottom. So it's the same factor. I can cross it off, and so I'm just left with 1 over cosine of x. 1 over cosine of x is equal to secant x. And so we've simplified our expression. Alright, when you do the homework online, you're going to have to get it to the most simplest form, so keep working on it until you hit that. So here's some guidelines for proving trigonometric identities. So here we're going to verify a lot of identities for a little while. So you're going to start with one side and try to make it to the other. So you're going to take probably the more complicated side, right? That is, try to simplify the complicated side and see if you can make it look like this. If that doesn't work, try to work on this side to make it look like this after you've done your simplifications. And if you get stuck, just convert everything to sine and cosines, and usually it can slowly filter out from there. So let's do this slowly. So I'm going to introduce some new notation just to make my life and your life easier. So LHS. So LHF means left hand side. Okay, so that means this side. I'm going to also introduce RHS, and that is the right hand side. And why that becomes useful is because here I'm going to say the left hand side. So I'm going to be working on the left hand side. I'm going to say that's what cosine of t times secant of t minus cosine of t. And here so I'm working on that. I'm going to go ahead and distribute that in. So I'll get cosine secant. So secant of t is 1 over cosine. So here I'll have cosine of t. Secant is 1 over cosine of t minus cosine of squared t. Well, this, of course, is equal to 1 minus cosine squared t. But what is this? Well, 1 minus cosine squared t. Well, notice if I have sine squared t plus cosine squared t equal to 1, that means sine squared t is equal to 1 minus cosine squared t. So you have to do a little manipulation here. Though after you do this a couple times, you'll get used to seeing this. And so here I can say all of this is equal to sine of t, right? So this, 1 minus cosine of t is equal to sine of t. So here I get sine of t squared. And so notice how I made my left-hand side. I worked on it. Here I've distributed in. So secant's 1 over cosine. So I have cosine over cosine minus cosine squared t. Cosine over cosine is 1. So I have 1 minus cosine squared t. I recognize from the Pythagorean theorem that sine squared plus cosine squared equals to 1. Therefore, sine squared is equal to 1 minus cosine squared. Plug that in, I get sine squared t. Well, I made my left-hand side equal to sine squared t. What was that? Well, that's my right-hand side. So that equals to my right-hand side. And once you have your left-hand side equals something that equals the right-hand side, you're done. So as long as you make this big change of equals, you're done. And so here we verified the theorem. Alright, so let's do a couple more and get you used to this. Alright, so let's zoom on in. Alright, so here I'm given two options to work with. I think the right-hand side in this case is more complicated, so I'm going to start there. So right-hand side. So I'm going to start on the right-hand side. That's equal to, I'm going to leave myself space because I know what I want to do. 1 minus sine of x minus 1 plus sine of x. And so what I'm going to do here, I'm just going to combine the fraction. So how am I going to do that? Well, here I'm going to multiply by its denominator, so 1 plus sine of x over 1 plus sine of x. Here I'm going to multiply by its denominator, which is 1 minus sine of x. 1 minus sine of x. And so notice here, if I want to combine fractions, I can just multiply this fraction by this denominator, this fraction by this denominator, and then by default they'll have the same denominator, so therefore I can do my fraction addition or subtraction, because remember, fraction addition or subtraction requires the same denominator. So here I get the same denominator, which of course is 1 plus sine of x, 1 minus sine of x, all over. So this would be 1 plus sine x minus, and then here I'll have 1 minus sine of x. And notice, please leave the negative here. Alright, so let's simplify this. We're going to do this. So on the bottom, 1 plus sine of x plus 1 minus sine of x. So this is the difference of so the difference of squares, and it factors out this way. So here we have, so if I just FOIL this, I'll get first, I'll get 1. So 1 times 1 is 1. Sine, I get positive sine x minus sine x, which cancels out to be 0. And then I get sine x minus sine x, so it will be minus sine x squared. Okay. Or minus sine squared x. Here, if I distribute this negative, so I make this positive, this will be negative, this will be positive, so I get the 1's cancel each other, but the signs add up, so I'll get 2 sine of x. Well, notice that 1 minus sine of x, well, 1 minus sine of x is equal to, here if I take sine squared x plus cosine squared x equal to 1, that means cosine squared x is equal to 1 minus sine squared x. And you'll get used to this. 1 minus the sine or 1 minus cosine is just the other function. So this is cosine squared x, so I can rewrite this as 2 sine of x over cosine x, or cosine squared x. Forgot my squared. Alright, then what can I do? Well, I can just rewrite this a little bit differently. I can write this as 2 sine of x over cosine of x over 1 over cosine of x. Now why am I doing, so once you get here you think, oh, I've got it as simple as possible. So actually, let me not do this. Not what I wanted. Let me just go backwards. I was writing on the wrong layer. Let me not do this. And so I get it here is pretty simple. So let's work on the left-hand side for a second. Left-hand side. I don't know what to do, so I'm just going to convert. This is 2 tangent x secant x. And so I'm just going to convert this to sines and cosines. So this is 2 sine x over cosine x equals, or times 1 over cosine x. Are these two the same? Yes, these two are the same. And therefore, you're done. So I have the left-hand side equal to the same thing on the right-hand side. Because I could easily just pull out 1 cosine. So instead of me knowing where to go and keep walking it, I'll show what you guys will probably do, which is just get to that where it's simple as you think and start working on the left-hand side. Okay. Alright, so here we have two things equally complicated, and so we're going to work on one, and then we're going to work on the other, and we're going to find out they'll be the same. Okay, so let's say Let's work on the left-hand side first. Let's just work on the left-hand side first. So here I have cosine of theta over 1 minus sine of theta. So what am I going to do here? This looks, I'm not quite sure. So let's just work on the right-hand side for a second. Do I know what to do? Yeah, sure, because I know how to move these, but you guys won't. So I'm like thinking here, you're going to see this and like, I don't know what to do there, right? So let's leave it. It's more complicated, but I don't know. Let's look at this one. Here, I don't know what to do, so I'm just going to convert this to sine. So secant theta plus tangent of theta. All right, so here I'm stuck. I don't know what to do here. I don't know what to do here. So let's just convert all this to sines and cosines, because I have sines and cosines on this side, so let's get sines and cosines on this side. So let's just say this is 1 over cosine theta plus sine theta over cosine theta. Well, that looks not too bad. I can put these two together. I get 1 plus sine of theta over cosine theta. Alright, well, that's fun and all. So here I have this. I mean, it's looking closer, but what should I do now? So let's work on the left-hand side for a second. Well, here I know I want my sine theta up top, so can I move it up top? Well, yeah, I'll teach you a trick. So here we're going to multiply by 1 plus sine of theta. So here we're going to make this at the bottom difference of squares like we did before. Same thing we did before. So I'll have cosine theta up top, 1 plus sine theta up top, and then here on the bottom, if I go ahead and distribute this, this would be 1 squared, which is 1, minus sine plus sine, so that's 0, and then minus sine squared, or minus, so it'd be 1 minus sine squared theta. But we know what 1 minus sine squared theta is. It's cosine squared theta, right? So it'd be cosine theta plus 1 plus sine theta on top. And then I know this from before. We've done it a bunch of times at this point, right? But this is cosine squared theta. And so this is cosine squared theta, theta. And notice here I can get rid of one of the cosines. And what am I left with? 1 plus sine of theta equal to cosine theta. And these two equal each other, so we're done. So we verified the theorem. And so what are we doing here? We just kind of look at the left-hand side, we kind of mess with it, we make the right-hand side kind of mess with it until they can finally get to them equaling to each other. Now you might think, well, how would I know how to do, move this over and do all these? And so what happens is you slowly work through these, and I've shown you a couple tricks. I guess tricks isn't bad. I've shown you a couple tools to put in your tool bag, and then you get used to having these tools, and you get used to looking for these tools. And so the first time you start working with this, it's going to be really hard, and you're like, I don't know what's going on, I'm not sure what I'm doing. But as you keep working on these things, just think of them as kind of tiny little puzzles. As you keep working on them, it'll slowly come together what to do. And you usually do the same thing, more or less, on each of these things over and over again. Okay? So it will come, just give it a little bit of time. So let's do our last example for this one, and then we'll go from here. So which side looks worse? Well, this side looks worse. So we're going to work on the right-hand side. So let's work on the right-hand side. Notice here on the left-hand side we only have cosine, so let's just convert everything here. Let's see what I can do to make this look more even. So here we have this. So I'm going to be, so here I have tangent squared theta. And then we have secant theta 1 minus secant theta minus 1. So I could convert this over to sine and cosines, but that's going to give me a little bit more loss than I hope. And so notice here that this has a single trig function, and here I have something. So let's move the something up top. And how do we do that? We use difference of squares. And so here would be secant theta plus 1, right? And so we're just do the same thing here, secant theta plus 1. So here I have secant theta plus 1, secant theta plus 1. I'm going to multiply these two because I want to get a single down here, so that's why I'm doing this. And so here I'll have secant, so here I'll have tangent squared theta plus secant theta plus 1 all over secant squared theta minus 1, because this will give me secant squared, this will give me minus secant plus secant, which cancels, and then I get negative 1 times 1 gives me 1. Notice here that I have, let's go back to my trig functions. What is secant squared? So secant squared minus 1, notice if I move the minus 1 over here, same as tangent. So we go back to here. And so I can rewrite this as tangent theta squared over tangent squared theta over secant theta plus 1. And notice the tangents cancels, and I'm just left with secant theta plus 1. Now, can I get that from the left-hand side? And the answer is yes. Because here, if I just divide the cosine by both sides, so here, this is the same thing as 1 over cosine theta plus cosine theta over cosine theta. Just splitting up your fractions. If you're uncomfortable with your fraction rules, it wouldn't be a terrible idea to review them. 1 over cosine theta is secant theta plus this, which is equal to 1. Is this equal to that? Yep, and we're done. Okay. Yeah, so you just get used to doing this. Is this the only way to do these problems? Absolutely not. But there are other ways to do that, and you'll figure it out in time, and you'll figure out what works best for you. So good luck on these. Keep trying. Use the discussion board. Help figure these out. Kind of just as you go over these over and over and over again, you'll get better and better at it. So practicing is the best way to learn how to do all this. Okay. All right. Well, that's the end of this video.